y'all, it's Miss Barker, and this is just going to be some more vector practice problems. This problem is going to be an example of adding vectors in only one dimension. So our problem says a student walks 60 meters north across the street to Stripes. The student then walks 15 meters south to meet their friend before returning to campus. What is the student's displacement? So let's draw our vectors real quick. The student's going to walk 60 meters north, and then 15 meters south. Okay, because these vectors are only in one dimension, we have north and south, we can just subtract. So we have 60 meters in the positive direction, north, and 15 meters in the negative direction, south. So 16 plus negative 15 equals 45 meters north. This is going to be an example of a problem with perpendicular vectors. So our problem says, Miss Barker decides to go for a walk after school. She starts by walking 100 meters south, then turns and walks 50 meters east. She decides to stop at Stripes, so she walks 200 meters north and 65 meters west. Finally, she walks 55 meters south to get back to the KCC parking lot. What is Miss Barker's total displacement? So let's sketch that out real quick. We have 100 meters south, followed by 50 meters east, then 200 meters north, then 65 meters west, followed by 55 meters south. Okay, so the easiest way to do these problems is to keep track of our x and y vectors. So our x direction is going to be east and west, and our y direction is going to be north and south. So I have 50 meters east and 65 meters west. I'm going to decide one of these is positive and one of these is negative just to show that they are in opposite directions. So let's make west negative. And then we're going to look at our north and south, our y direction. So I have 100 meters south, then 200 meters north, then 55 meters south again. And again, I'm going to pick one of these, so let's pick south to be negative. So I'm going to go ahead and find what the total displacement in the x and y components are, and then I can use that to draw my triangle and find the actual total displacement. So 50 minus 65, that's going to be negative 15 meters. Remember that all that negative sign does is tell us the direction. Over here, similarly, I have 200 minus 155, so that should give me 45 meters north. This would be west. Okay, so if I draw that triangle, I have 15 meters in the x direction and 45 meters in the y direction. And now I can solve for my hypotenuse. So I'm going to do that using the Pythagorean theorem, a squared plus b squared equals c squared. So 15 squared plus 45 squared is going to give me 2,250. So I am going to take the square root of that to get c, and that's going to give me about 47 meters. Okay, so I know I have a total displacement of 47 meters, but I need to know what direction, and that's going to be my angle here. I know all three sides and I know I have a right triangle, so I can use any of my trig functions. I'll use sine here. So sine of theta, that's my angle here, is going to equal my opposite, so 45 meters, over my hypotenuse, 47 meters. In order to get theta by itself, I'm going to take the inverse sine, so sine inverse of 45 over 47 is equal to theta, and that should give me 73 degrees. So my total displacement after my walk is 47 meters at 73 degrees northwest. This one is going to be an example of finding component vectors. So our problem says Miss Barker's dog, Tennessee, escapes from the vet tech room and runs 25 meters at 32 degrees northeast. What is Tennessee's displacement in the x and y directions? So we have little Tennessee running 25 meters, not super far. He's got short little legs. At 32 degrees. And we want to find x and y. So I know my angle, I know my hypotenuse. I'm going to need to use some trig functions to find my x and y. So y is opposite of my angle. That means I'm going to use sine, right? Because sine is opposite over hypotenuse. So sine of 32 degrees should equal y over 25 meters. I'm going to multiply both sides by 25 so that I can get y by itself. And so if I round to two significant figures, y should come out to 13 meters. I'm going to do the exact same thing for x, but x is my adjacent. So I'm going to use cosine, because cosine is equal to adjacent over hypotenuse. So cosine of 32 degrees is equal to x over 25 meters. Again, I'm going to multiply both sides by 25 to get x by itself. And again, I am going to round to two significant figures, so x should be approximately 21 meters. Here we have an example of when we have multiple non-perpendicular vectors. So our problem reads, a student folds his lab paper into a paper airplane. This is not advised. And then he throws it. The airplane travels 2 meters at 41 degrees. Then the wind changes and the airplane flies an additional 6 meters at 23 degrees. What is the total displacement of the airplane? Okay, so I'm going to start by drawing two different triangles. I'm going to start with a 2 meter at 41 degrees. And then 6 meters at 23 degrees. Okay. So for each of these, I'm going to find the x and y component. Then I'm going to add my x's, add my y's, and draw a third combined triangle. So let's look over here at this triangle first. Now, anytime I'm trying to find my components, that's when I'm going to use my trig functions. I know that for x, I'm going to use cosine. For y, I'm going to use sine. So cosine of 41 degrees equals x over 2 meters. Sine of 41 degrees equals y over 2 meters. And I can rearrange by multiplying both sides by 2 to get my variables by themselves. And so I should have 1.5 meters in the x direction and 1.3 meters in the y direction. I'm going to do the exact same thing over here with my second triangle. So cosine of 23 degrees equals x over 6 meters. Sine of 23 degrees equals y over 6 meters. And so this should result in 5.5 meters in the x direction and 2.3 meters in the y direction. Now I'm going to combine my x's. So here I have 1.5 plus 5.5 should give me 7 meters. Going to do the same thing for the y's. So 1.3 plus 2.3 should equal 3.6 meters. And I need to find C. I need to find the total combined displacement. So I have my two sides of my triangle. I'm going to use the Pythagorean theorem to find the third. A squared plus b squared equals c squared. So that would be 3.6 squared plus 7 squared equals c squared. C squared equals 61.96. So if I take the square root of that, that's going to give me approximately 7.9 meters. And now I can find the angle. I can solve for theta. So if I look here, let's do cosine. You can really pick any of your trig functions at this point because you know all three sides of your triangle. So cosine of theta is equal to 7 meters over 7.9 meters. Now in order to get theta by itself, I need to do the inverse, the opposite of cosine to both sides. So theta equals the inverse of cosine, 7 meters over 7.9 meters. So theta is approximately 28 degrees. So my final answer should be the total displacement of the airplane was 7.9 meters at 28 degrees.